Welcome to the lecture on environmental impact of the energy industry. We continue to consider how particular energy sectors affect the environment. In this lecture, we will study the environmental impact of hydropower, nuclear power and bioenergy. After this lecture, you will be able to list possible environmental impacts of hydropower, nuclear power and bioenergy and describe consequences of the negative impact. We start with hydropower. Let me remind you the principle of hydroelectric power plant operation. Water pressure is created by dam construction. The pressure rotates turbine blades. This rotation activates generators. The river is blocked by dam, and as a result, territories are flooded by the reservoir. Flooding is one of the most serious negative consequences of water energy use. Especially these problems are typical for plain rivers. Flooded areas are often the most fertile land used in agriculture. Flooding of densely populated valleys by large plain water reservoirs leads to the need to relocate large numbers of people to new lands and create the necessary infrastructure. Forced displacement is a very difficult social problem. In recent years, the protection of territories from flooding is widely used, allowing to reduce the number of displaced people. On flooded areas, previously existing vegetation is lost. Soil and vegetation of neighboring areas also changed. This may lead to loss of rare species. However, in recent decades, the preparation of the reservoir bed provides for the removal of fertile soil layer. This allows to preserve the soil as a valuable natural resource and use it to improve low productive land, and thus partially compensate for the loss of land flooded by the reservoir. Reservoirs also have a negative impact on animals and fish. Some animals die, some change their habitats, migration of fish is disturbed, fish die then hitting the blades of turbines. In mountainous areas, the environmental impact of a hydroelectric power plant is much smaller, as reservoirs usually cover small areas. In this regard, in recent decades, there is a trend to move the construction of hydroelectric power plants in the mountainous areas. In some countries with mountainous terrain, significant part of energy is generated by hydropower. In Norway, hydropower plants provide 97% of the electricity, for example. Another problem is large water losses in reservoirs caused by evaporation from significant water surfaces. Temperature drops as evaporation increases. Changes in the temperature also have an impact on natural ecosystem. Also, water flow in reservoir decreases, which leads to accumulation of pollutants and decrease in water quality. Creation of water reservoirs reduce inflow of fresh water into the seas and lakes where these rivers flow. Water level decreases and salinity of the seas increases. Such changes may lead to the death of fish and plants. Nuclear power. If construction and operation technology is followed, environmental impact of nuclear power plant should be significantly lower than of other power facilities. Emissions of pollutants during operation of nuclear power plants are much less than in case of coal, oil and gas use, and ordinary health risks are much less than in case of coal use, for example. All reactors should have a containment building. The walls of the containment building are very thick and made of concrete and can therefore stop any radiation emitted by the reactor into the environment. Under normal operating conditions, radiation contamination is kept to a minimum and does not exceed the permissible natural background. But this is true only if all operating rules are followed. Because if something goes wrong, there is a possibility of catastrophic risk. If the radiation protection fails, consequences of the accident will be much more terrible than consequences of fossil fuel use. And such cases have already happened. That's why people don't trust and are even afraid of using nuclear energy. The last two major accidents are at the Chernobyl and Fukushima nuclear power plants. The containment was destroyed and radioactive fuel was spilled. Air and territory were contaminated. Different reasons led to serious accident and consequences. Radiation contamination of territories, death of people, several 100,000 affected people, contamination of food and water. And now, these are closed areas in about 30 kilometers around the station for both cases. And recovery of these territories takes decades. Besides risk of disaster, negative consequences of nuclear power include the problem of waste storage and thermal pollution. Biosphere safety requires processing and special storage of radioactive waste. Radioactive waste is usually kept and isolated from the environment for a long period of time in special containers or facilities. Disposal technology is very complicated and expensive. Further control of the waste is necessary, as if the container is destroyed, the waste can contaminate both land and groundwater. Also, decommissioning of nuclear power plant requires large material costs, planning and time. Decommissioning process can last from 20 to 70 years. Thermal impact of nuclear power plants occurs throughout cooling. During radioactive decay, a huge amount of energy is released. Cooling facilities are one of the most important elements of the plant. If they fail, disasters will happen. The efficiency of nuclear power plants is about 35%. The remaining heat is released into the atmosphere. This affects the environmental microclimate. Bioenergy, as well as hydropower, is often considered as renewable energy. There are liquid biofuels, for example, ethanol, methanol and biodiesel, solid biofuels, firewood, briquettes, pellets, and gaseous biofuel, synthesis gas, biogas and hydrogen. There is a widespread idea of carbon neutrality of bioenergy, according to which obtaining energy from plants doesn't lead to the addition of CO2 emissions into the atmosphere. Whether this is true or not depends on many factors. Although the combustion of biodiesel produces carbon dioxide emissions similar to those from conventional fossil fuels, plants used in production absorb carbon dioxide from the atmosphere, then they grow. Plants absorb carbon dioxide throughout a process known as photosynthesis, which allows them to store energy from sunlight. Energy and carbon are released again after biomass is converted to biodiesel and burned as fuel. Some of this energy can be used to power the engine, while carbon dioxide is released back into the atmosphere. However, it is important to take into account the entire production process when considering total greenhouse gas emissions, as well as consequences that production may cause. Not only the combustion of biofuels can generate carbon dioxide, but many stages of the biofuel production process lead to CO2 emissions. Equipment operation, transportation and chemical processing of raw materials are associated with CO2 emissions into the atmosphere. Another problem for the carbon neutrality of biofuels is that CO2 from wood burning enters the atmosphere directly in the process of burning, and its extraction from the atmosphere takes tens and hundreds of years as new trees grow. This time lag is usually called carbon debt, and for European forests it reaches 200 years. Therefore, the carbon neutrality of wood as a biofuel cannot be ensured in the short and medium term. In addition, growing plants for biofuel production means that territories have to be prepared and free from other vegetation that could naturally extract carbon from the atmosphere. Also, uncontrolled cutting of trees can lead to destruction of ecosystems, loss of plant species, and soil erosion. So, in this lecture, you have learned about possible environmental impacts of hydropower, nuclear power, and bioenergy, and consequences of the negative impact.